Did want to go ahead and start off like, if you're in person, I have given you your test. If you're virtual, then you can already see it in your OneNote. I did upload the answer key to that test. It's in the answer key folder for Unit 5, so you can look over it. Definitely look over it, clearly the ones you missed. Was going to spend some time though first talking about the recovery just because unfortunately it does apply to quite a few people in this class. Very similar to what it was first semester for those of you who had me, except the cutoff is a 79 versus the 89. It probably bums you out, but a lot less work for me, so 79 is what the cap is. Some things you should already see that has happened. I did already do the quiz recovery in certain ways. So if you did all of your homework and then you did the quiz corrections as part of the briefcase finder, I added 5 points to the quiz. You should have already seen that reflected. The quiz grade you have should be 5 points higher unless you did like 80% of your homework, then it would be like 80% of 5 points. And then after the test, if your test grade was still higher than quiz grade plus 5, I replaced your quiz grade with the test grade. So the highest you should see your quiz is basically the same grade as your test. Definitely go back and look. Like if you think you finished the homework and you see that homework average is not 100, then like maybe you didn't do it, you should go and check, or maybe you did do it and just didn't sync up in OneNote and just let me know. Also remember the briefcase binder is part of one of your summative assessments. There were a few people who didn't do their briefcase binder, but you saw me put a 1 in for that, so you know who you are. And then for how the test recovery works, I'm kind of going to focus on that. So again, the cap is 79, so if you have 79 or higher, then you're not doing recovery. Still look over your mistakes, but there's really nothing you can do to pull that grade up. The first thing you want to do when it comes to recovery, or let me preface this. So the district says that all recovery has to be done, within 5 days or before the next summative assessment, which honestly just doesn't work in a calculus class where sometimes like we have a test and literally the next week is like another summative assessment. So for me, just don't tell the county, I guess I'm being recorded, but for me, I'm just gonna make the deadline be like, it's due before the next unit test. So like, because the quiz grades usually happen pretty soon, so we'll just say it's due by the next unit test, which your next unit test is not gonna be until the 17th of February. First thing you can do to improve your test grade, you can do test corrections in the same format as quiz corrections, so like the part A, B, and C. You can do them on paper, upload the picture in Teams. If you're in person, I have a red tray you can put corrections in. But basically that would add 5 points to your test grade, capping it at a 79. So for many of you who are in like that upper 70, mid 70s, upper 70s, like just do the corrections and you have your 79. Or maybe you just have a 65, you just want to get a passing grade. That will give you to the 70. If after doing the test corrections, it's still below that 79, you can do a recovery test. To help me, because honestly, first semester, I felt like I was spinning in circles, scheduling recovery tests like all over the place. I'm going to try, and we see how it works, of just doing like certain days of recovery, especially since we now have like those special Wednesday schedules for like that kind of office hour period. So that's going to be my recovery time. So within this unit, there's going to be 2 options to do a recovery test. Most of you probably aren't going to use this first one because it's literally on Wednesday, but like if you know you just made a few mistakes or you really work hard this weekend, you might be ready to retake that test on Wednesday during office hours. Most of you, if you're doing this recovery, you're probably shooting to do it on Wednesday the 10th, and that will be like that last Wednesday we have before the test. Again, if those don't work with you, like clearly I'll work with you because the deadline is not until the 17th. I'm going to try to keep at least most of the recovery happening on one day, just so I don't feel like I'm spinning in circles, trying to schedule stuff and make copies and all that stuff. I think recovery is often like a very personal thing. So like if you do have questions or it's unclear about how I do recovery, definitely shoot me an email or text me on Remind or kind of just get with me one-on-one. But that's kind of how we'll do recovery for each unit this semester. I will say I do appreciate the deadline. It kind of allows me to have like a firmer deadline on it. especially in this unit, like if you're not getting stuff in the previous unit, like the next unit is going to be like definitely an uphill battle. So like you definitely want to make sure you stay on top of it. Like this unit, as you saw, as we started it, like we're just integrating more stuff. So like you have to kind of keep working on those skills and building those skills that we have. So now I'm going to kind of switch over to the notes. They actually will be much shorter today than they were yesterday after I did them in fourth period. Just to kind of make sure we're all on the same track and same page. Mainly what we focused on yesterday, we said that this unit, like the big idea is like, in many ways, like yes, we're doing integrals and yes, we're finding the antiderivative, but really we're focusing on like making the decision of how to approach the problem. We learned a new rule, and the new rule that we learned, let me go to that slide, was the integral using the natural log of x, so not integrating the natural log of x, but using it. And we learned that 1 over u, we said, with respect to u, is equal to the natural log of the absolute value of u plus c. Clues that we're going to be integrating with natural log, big things that we're looking at. To go back to this slide we looked at yesterday, is when your denominator is raised to the first power. That's not going to always be a natural log problem, but that's going to be a big idea that you're probably going to use a natural log rule. So like one we looked at previously, like this one I have kind of in the middle of the page, 1 over 3 plus x, that's the denominator, 3 plus x to the first power. The u sub works, everything cancels out fine, so we would do the u sub and it was the natural log rule. That was different, say what we did last unit, that one on the bottom left-hand corner. That one has an exponent of 2 in the denominator, so that was one that would not be a natural log rule. So when we rewrote it, we would just do the regular u sub and then integrate it. And I think what's challenging is, like even looking at those 4 we have, I can change tiny parts of the integrand, and it becomes a completely different problem. And you can kind of expect, mainly because I'm telling you right now, like the first page of the test that and the quiz even that I give you will be like 4 questions, all look almost the same, but all like slightly different. So they use kind of like some different rules, making sure we recognize when to use certain rules and when not to use certain rules. So a lot of this unit is not only can you find the antiderivative, but can you make the correct decision in how you find the antiderivative. So some other examples we looked at, and again, I'm just kind of doing an overview of yesterday because it was a lot. We said the easiest examples that we did was when we had a monomial. So when you're looking at a problem and that denominator had a monomial, you smiled because it was easy. Divide everything by that monomial and then just integrate each part. The one we did, like the first 3 terms was like easy stuff. That last one was where that new rule was going to come into play with the natural log. And then we expanded, like, hey, again, still just kind of making decisions. Sometimes maybe you don't have a monomial and you need to decide what to do. And there was this fun one, and we had to do long division to kind of simplify it. So again, rewriting the problem, any algebra skills like we've seen in that previous unit, we had like factoring or foiling. Long division is another way to kind of simplify a problem so that we end up with a complicated, that we start with a complicated fraction, made it simpler, but still kind of using those new rules that we had. And then we looked at other examples. I kind of mixed in some examples of, let me find it. We had this one, again, weird kind of rational expression. Didn't use long division because it wasn't a top-heavy one, but we did know it was eventually a natural log rule because its denominator was raised to the first power. So again, we're like making kind of like all these decisions. Where I'm going to pick up today at is with actually some new integral rules. Yes.
Quick question.
Uh-huh.
When you have a monomial, but like if it's like a bigger degree on the bottom, would you still just divide everything by that?
I would still divide everything by it, yeah. So we're going to pick up on, let me do here. So at the top of your OneNote, kind of that's notes tab, I share with you, I mentioned it yesterday. There's 2 pages. I'll kind of open it up so we can see what I'm talking about. There's a page that I call the derivative super summary, and it has all the derivative rules I expect you to know. Just real quickly, I've kind of already found that some people who came from GAVs, there are some rules I don't think you've seen, but you're gonna figure them out real fast. But there's that. I would recommend filling it in, especially if you had me, just kind of making sure you could fill all those in. And then there's also a second page that had a bunch of integral rules, some that you know, some that you don't know. And those are basically all the rules you'll eventually have to have memorized. There's no formula sheet on the AP exam, so you do need to have all the derivative rules memorized and all the antiderivative rules memorized as well. So that was what I wanted to show you again, just to remind you it was there, to kind of fill that out on your own. What I was going to jump to is this slide. So if you're following along in OneNote, is the one that says the integral of tangent of x and cotangent of x. So these are two functions that we currently do not know the integral for. And a lot of students look at that and they're like, I'm pretty sure we do know the integral of it. And I'll be like, no, you actually don't. We know the derivative of tangent. So like just kind of talk about the tangent one. We know that the derivative of tangent is equal to secant squared. I know we have an integral then of secant squared, which is equal to tangent x plus c. So that's a rule. We even have this integral rule. We know that the product of secant and tangent itself is equal to secant. And those were like three rules that we have, two from integrals and one from derivatives. What we don't know right now is how to integrate tangent. So it's kind of like, yes, I know the derivative of tangent is secant squared, but if I were to move backwards one step, what function would have a derivative of tangent? While that looks like a simple integral, we actually learn it in this unit because integrating tangent is actually a natural log rule problem in disguise. And I say that because what's going to be a way that we can rewrite tangent to maybe make it look more like a quotient? Sine over cosine. So there's two ways to write tangent, one over tangent, or excuse me, one over cotangent or sine over cosine. Sine over cosine is the one that's going to have a fraction with kind of two parts. And I know I'm the calculus teacher, so I've been doing it forever, but kind of so you can think the way I do. To me, when I see sine over cosine, that screams out that it's a natural log problem. Why is it telling me, or how is I'm realizing that's a natural log problem? We have a denominator that is raised to the first power. That's the first clue. The other clue that's a natural log problem is the derivative of the denominator is what we see in that numerator. So if I want to go ahead and kind of do this as a natural log problem, we're going to do u sub. I'm going to go ahead and let u be equal to the cosine of x. What's the derivative of cosine? Negative sine of x. Doing your substitution, I'm going to have the sine of x over u, dx is du over u prime. The signs cancel out. What's left over? We have this negative, so I'm just going to kind of move it on the outside. 1 over u du. This is the rule that we learned yesterday. What's the integral of 1 over u? We have that negative there. And then the integral of 1 over u is the natural log of the absolute value of u plus c. And then we said u was the cosine of x. So what is the integral of tangent? The integral of tangent is the negative natural log of the cosine of x. And I'm going to go ahead and tell you right now, we have to integrate tangents so often. Instead of having to do that each time, it is going to be easier for you to just memorize that as a new rule. So like go ahead and just commit that to memory. The integral of tangent is the negative natural log of cosine of x. Again, if you forget it, like by all means, we now know how to get to the answer, but it's going to save you a lot of time in the long run just to memorize that because we're going to integrate tangents so often. Go ahead now for me and see if you can figure out what the rule for cotangent is going to be the same way. Again, we'll do it once this time, kind of a long way, but moving forward, we'll pretty much almost always just jump straight to the answer because we know what the rule is. And that's what you should have gotten for that one. So cotangent is the same thing as cosine over sine. I know it's going to be a natural log rule because the denominator has an exponent of 1. The derivative of sine is cosine, so I know like the u sub stuff is going to cancel out. We're going to end up with just 1 over u. We don't end up with a negative here because the derivative of sine is positive cosine. So again, the integral of cotangent is going to be just the natural log of the absolute value of sine of x plus c. And again, it's going to make your life easier to just memorize that instead of having to do like those extra steps each time. So let's look at an example with one of those. I forgot to include a slide with an example, so I'm just going to make one up right now. There. And let's see if I can make up a good one. We'll do the integral of, let's just say x squared times the tangent of 3x, we'll do 3x cubed dx, why not? So here's an example of where that new rule would be used. But first, it's code.
I was just a little confused because if natural log is like 1 over x, where are you taking that like x from?
So we know, just make sure I understand what you're asking. Like we know the derivative of the natural log of x is 1 over x, right? Is that what you're saying? And so when we're doing the rule, you're asking where the absolute value comes from? Or no?
I actually think it is. I was just saying like 1 over.
Yeah, so it's basically like you're working backwards. Like 1 over something working backwards gives you the natural log. I showed one reason why we had the absolute value there. The other reason is technically like the inside of a natural log can't be negative, so you have to kind of like force it to be positive. Like technically the natural log of like -2, that's undefined. So it's kind of like working backwards, but then forcing it to work out. So looking at this one that we had, there he is. If I have x squared times the tangent of 3x cubed, again, let's talk about some mistakes I saw on the unit calculus. First mistake, people will see a product and they just want to like find the antiderivative of each part. Again, you can't do that just with the same as derivative. We have to like find a way to deal with that product. So if I'm looking at this problem, I know a rule for the tangent of something. Like I know how to integrate tangent. There's something inside of tangent, so similar to when we just integrated like sine or cosine. We're going to let u be what we see on the inside. So I'm going to go ahead and let u be what I see on the inside. And then find u prime. That's going to become 3 comes down in front, 9x squared. And I can go ahead and do my u substitution. So I have the integral of x squared. This is now the tangent of u, du over u prime. The x squareds are canceling out. And so we're really just integrating 1/9 on the integral of the tangent of u du. Well, how do I integrate that? 1/9 is just a coefficient, so it's coming across. Could do this the long way. So you could rewrite this as like tangent is sine over cosine and do like a second u substitution. But again, that gets messy and that's just like more complicated than it needs to be. We now know, or you will eventually have it memorized, the integral of tangent is the negative natural log of the absolute value of the cosine of u. Well, what was u? 3x squared. You can always check your answer, remember, by taking the derivative. Like if you take the derivative, you kind of imagine it's going to be like 1 over the inside times the derivative of the inside, which is going to turn into a tangent. But again, it's a whole lot easier just to memorize that rule so you can kind of skip rewriting tangent as a sine over cosine. Yeah, Taylor.
Okay, cute.
It should be, yeah, 3x cubed. Thank you. That's what I use. Sometimes students are like, well, how do I remember which one goes with which one? And I don't know if I have like really tricks to memorizing it. Things that I remember when I first learned these that kind of helped me is I knew that tangent had the natural log of cosine. Again, you just kind of remember what is tangent. Tangent sine over cosine. So we know like the denominator ends up inside the natural log. And I know that the tangent ends up with a negative because it kind of comes from like the derivative of cosine is negative. So I kind of connect those in my head together. Same thing for cotangent. Cotangent is cosine over sine, and I just remember that to remind me which one goes inside the natural log for integrating cotangent. So those are two more derivative rules that we have. Yes, Smith?
So for the AP test, do we have to show our work, or can we just skip directly to this?
So you don't have to show your work. So like if I was doing this on the AP exam, now show your work if you need to, but many of you could jump from the original question to the answer if you can imagine what the coefficient is. So show as little or as much work as you need to, as long as you do it correctly. So those are the two rules that we have, tangent and cotangent. Last two rules that we're going to learn today are for cosecant and secant. These are actually really, really hard to like figure out where they come from. Not really hard. It's just like obnoxiously difficult to figure out where they come from. So I'm just going to kind of like tell you what it is. And so like the first rule you're going to add to kind of your memory is the secant rule. And I'll get out of the way in a second. Again, it's a gross one, I think, but it's the integral of secant of x is the natural log of the absolute value of secant of x plus tangent of x. So do make sure that you have like a plus sign here instead of the times that you might be used to. And again, that's just something that you want to memorize. Like we could obviously check our answer. If you take the derivative of this, you're going to end up with secant. You'll have to like do some simplifying. I'm not going to worry about it. I'm just going to tell you to kind of like memorize it because honestly it's going to be easier to memorize it. And so that's going to be the integral of secant. So like an example with secant, I might say, hey, let's integrate the secant of, I don't know, we'll say 4x. So again, we're not going to worry about rewriting it. That's going to be just a memorized rule that we use. So if I'm integrating this one, I think this is a pretty easy one to do the u sub in your head. U would be 4x. U prime would be 4. So I know the coefficient coming out in front would be 1/4. So its antiderivative would be 1/4. The natural log of the absolute value of the secant plus the tangent plus c. And u is going to be replacing both of the things you see on that graph. Kind of like an awkward one to deal with, but again, just kind of like memorize the rule and carry it over. How I kind of move this rule to the one we did. Wherever I saw the x, I kind of replaced it with a u. So that is secant. Once you do memorize secant, cosecant is pretty easy to memorize because it looks very similar. And cosecant's integral rule looks like this. Some differences. It is a minus sign on the outside, so you want to kind of memorize that. But the integral of cosecant is going to be the negative natural log of the absolute value of cosecant of x plus cotangent of x, and then plus c. Again, we could verify it, but honestly, I find this hurts more than it helps. Just go ahead and memorize it. I will say on the AP exam, cosecant and secant are some of the least common integrals you will encounter. But it is listed as one that you should know, so they could throw it in there. But typically, they're going to like integral of tangent and cotangent, more common. But integrating cosecant and secant is actually very rare to see on the AP exam. So that's all the trig rules that we're going to learn for now. We will come after the quiz and do inverse trig, but those are kind of like an entire beast of their own. But at this point, we have learned all the integral rules that you do need to know. So we have like the sine, the cosine, we have tangent and cotangent, we now have secant and cosecant, and then we also have those other rules that just come from the derivative, the secant squared, the cosecant squared, and then the product of cosecant, cotangent, and secant and tangent. Go ahead for me, and I'm just going to say, hey, try those 5. So I'm going to give you about, let's say like 5-ish minutes to see what you can do with those. Some of these are going to be really straightforward. I think one of those we actually have already done, but pretend that we haven't. Some of these will be actual ones you could have done like last unit. So they're going to be using like some of the old integration rules. Some of these will use the new integration rules. Some of these you have to rewrite. Some of these you don't have to rewrite. Some of these use use substitution and some of them don't. I want to give you time just to see which ones you know for certain you know how to do, because these are kind of some different levels of trig. And when I answer them, so like you want to check your answer, if you're looking in OneNote, the next slide I shared with you has the answers typed in. We're still going to go over it though, because I want to talk about like the decision-making process, because ultimately that's like a big deal in this unit. Like how do we decide what's going to be the best rule to use when we're finding these antiderivatives? So I'm going to shut up for a second while you work on those 5, and then we'll kind of regroup in 5-ish minutes. And again, as you're working on trig, you want to kind of think to yourself like, is this a memorized rule? Is there an easy way to manipulate it so it looks like a memorized rule? And then if it's not a memorized rule, then be like, does it make sense to do u sub? And if it is u sub, then like, what type? Natural log, moving an exponent up, lots of different options with trig. And I think that's what makes trig difficult until you have lots of practice and kind of get used to how they work out. Because there are usually different routes you can take for these problems that look very similar, but can end up being worked out in fairly different ways. Maybe a few more minutes to see what you can do with those 5, and then we'll talk about it a little bit. This is where I'm going to end up stopping today's notes at. So you'll have plenty of time to get started on any homework, or test corrections if needed, or ask me any questions and all that. All right, so let's go ahead and regroup and talk about some of these. That first one, I think this is the one that we actually already did, to be honest. I probably should have changed it for this slide. But this is one that I think is very clear, to me at least. I know that can be insulting because like you're just starting out, but like hopefully it's clear to you eventually that this would be a natural log problem. Big clue, that's a natural log again. And we have already done this one, but we know that that denominator is raised to the first power, and the derivative of the denominator is seen elsewhere in the problem. So we know that the u sub's going to work out, things are going to cancel out nicely. U would be equal to tangent, and u prime would be secant squared. That's where it's canceling out at. So you should have gotten this is going to become basically the integral of 1 over u du, which will be the natural log of the absolute value of the tangent of x plus c. Moving across the page, 1 over tangent of x. So you might first look at that and be like, oh, cool, that could be a natural log problem. We just have tangent raised to the first power. But again, issues start to happen because we know the derivative of tangent is secant squared, and there's nothing for it to cancel with in the numerator. So we need to find something to do to kind of manipulate it. This one I think is pretty much a one-step one to rewriting it. What's going to be the best way to rewrite it? Cotangent. And why we want to do cotangent? Because we now know how to integrate cotangent. So either do it the long way or you have the rule memorized. Cotangent is cosine over sine. So its rule would just become the natural log of the absolute value of sine plus c. And again, that's just coming straight from a memorized rule. Looking at this second one, exponent in the denominator is not a 1, so I know automatically it's not going to be a natural log problem. I do see this often, so I'm about to write down something that is not wrong, but not going to help you get anywhere. But I see students move up that sine squared to be sine to the negative 2. Like mathematically, like that's a thing. You can do that with exponents. But why wouldn't we want to do that? Like sine is on the inside, and its derivative is nowhere to be seen outside the parentheses. So that's going to like not really get you anywhere useful. What might be the better way to rewrite that one instead? Cosecant squared. And this would be something you could have done on your Unit 5 test. What's the integral of cosecant squared? Well, the derivative of negative cotangent would give you cosecant squared. So we can just work backwards from a derivative rule. This next one, do you need to do anything to rewrite it?
No.
No, like it looks gross, but we now have rules for both of these. We know the integral of secant. That's the natural log of secant of x plus tangent of x plus c. We also now know the integral of tangent. That's going to be negative natural log tangent sine over cosine plus c. So again, those are just two memorized rules integrating each part. Any questions on those four before I look at that last one? Yeah, Mitch.
So the plus C is at the very end, right?
Yeah, we wouldn't need to put like a plus c in there twice.
Okay.
So then this last one, definitely some issues on this one that I sometimes see. Students want to like integrate each part as it's written. But right now this is a product, so you need to somehow deal with that product, either by getting rid of the parentheses or doing u sub. Hopefully it's kind of clear to you that like secant plus tangent x, you can easily distribute that secant across. Distributing the secant across, secant times secant is secant squared. Secant times tangent is secant of x times tangent of x. You can rewrite secant times tangent. There was that problem on your test actually, and a lot of students did rewrite it, like secant, and kind of show you what happens. Secant is 1 over cosine, and tangent is sine over cosine, which is going to give you sine of x over cosine squared. Like that's not wrong, and you could do the u sub where u is cosine and it all works out. But it's way easier just to remember that that is a memorized rule that we have. The derivative of what is secant squared, tangent. The derivative of what is secant times tangent, that would be just secant, and then we have our plus c. So both of those after distributing become old rules, technically rules that we did last unit, then kind of integrating it. So on Monday, we are going to regroup. On Monday, I'll go ahead and show you what we're doing, just, I don't know, in case anyone gets bored of the weekend and wants to do it early. I say, knowing that no one's going to do that. But what we're going to be doing on Monday, It's like an old warm-up I did in person, so that's why there's like 2 copies of it. But those 4 problems, which are kind of like polynomial ones, again, kind of focus on the decision making. And I do kind of emphasize that, like when you're doing the homework, I know it's really easy just to be like, okay, I did this problem, do the next one, do the next one. But for something in this topic, like you really want to like not only do the homework, but actually like think about why you're doing certain problems certain ways. Like, why are you doing long division? Why are you dividing everything by the denominator like a monomial? Why is this a natural log rule? Just to emphasize it to yourself as we start mixing more and more rules together. So that's what we'll be doing on Monday. I have a second one with Trig, just because I do find that Trig tends to be a struggle for a lot of students when it comes to integrating. What I want you working on now, though, is honestly just the homework. So you have homework 1. That's the one that I'm officially assigning. So I'm going to kind of say things to do, be working on. So you have homework 0. That's not due until the very end of the unit, which again is on the 17th. You have homework 1 now. That's going to be due on the day of the quiz, though. So that might be a higher priority for you. And then other things you can think about are, of course, test corrections and anything involved with that. So either like getting with me to go over questions or just like looking over the answer key and things like that. Monday, again, we're just going to do some problems real quickly, and you will have a bulk of Monday just to work on homework and ask questions. Tuesday, we'll cover integrating exponents, and then Wednesday will be another kind of like work day, and then quiz on Thursday. So honestly, you'll have 2 days next week that will be days to get homework done, 1 day of instruction, plus Friday, but that's going to be after the quiz. So y'all can go ahead and get started with that. If you are at home, then class is over and you're more than welcome to leave the live meeting. Have a great weekend if you are leaving. If you need a